Well, let's see if you can remember from yesterday how to find the missing parts of these triangles. I'm going to label this one. All right, so for number one, we have two angles and a side. Is you okay over there? We have two angles and a side. And that's in that situation, we can always solve it using the law of sines. So the first thing I'm going to do is I'm going to find my third angle here. And I'm going to find that, of course, by subtracting those from 180. So it's going to be 180 minus 38 and 79. 65? 62? Okay. Did I punch that in right? 63. So it's 63 degrees there. Just because that's an easy piece to come up with because it's just a simple subtraction. Now that we have that, we can go ahead and solve for the missing sides. And we're going to start out by using this. We only know one side, that's the 42 millimeters. What angle is going to go underneath it? The 63, so sine of 63 degrees. Now I'm going to find side little a, so I'm going to put little a here. What angle goes underneath that? The 38. So then this is going to be simply cross multiply and divide. 42 times sine of 38 divided by sine of 63. We do have to be careful to close our parentheses. We get 29.02 for A. So A here is 29.02 millimeters. To find B, we're going to start out with that same proportion, 42 over the sine of 63 degrees. B is going to go over the sine of what angle? 79. Now, before we do anything here, what do we know about the size of side B? It's going to be the longest side. So far, it matches up. The 29 is across from 38 degrees. That's the smallest angle. And 29 is smaller than the 42, so it's been the smallest side so far. So we know B has to be the largest side because it's across from the largest angle. So again, we'll cross multiply and divide. So 42 times the sine of 79 this time. Make sure we close those parentheses. Divided by the sine of 63. 46.27. And that makes sense. That is our longest side. And that's what we needed to get out of it. Over here, we have two sides and only one angle. So the first thing we have to check is we have to check to make sure we can use the law of sines. And the first thing is the angle opposite one of the sides. And in this case, yeah, the 78 is across. It's opposite the 48 degree or 48 millimeter side. So we can use law of sines. You know, the one possibility is if the angle is between the two sides, we cannot use law of sines. The next question we want to ask before we jump in and solve this is from the angle is the opposite side shorter than the other side? If this opposite side is shorter than the other side, there are some ugly possibilities that can come up. In this case, this opposite side, the 48, is the longer of the two sides. So that's telling us we should be safe. So anyway, let's go ahead now and solve that. We have the 48 millimeters over the sine of 78 degrees. Now the only other piece that we have here is the 41 millimeters, so we got to put that on top. And that's going to be over the sine of angle A. Now one nice thing here is we know that this angle here has to be less than 78 degrees. How do we know that? Yeah, 41 is smaller than 48. So that tells us that angle A cannot be obtuse. Has to be acute. And when we're dealing with finding a missing angle, because we're going to do an inverse sine, remember we discussed yesterday, in inverse sine, there's always two possible angles. There's the angle the calculator gives you, and then there's its supplement. Well, we know that the answer here is going to be the angle the calculator gives us, because it has to be an acute angle. So we're going to find the sine first. We're going to do sine of 78 times 41 divided by 48. Gives us 0.8355. So then angle A is going to be the inverse sine of that. Which is 56.67 degrees. So it's 56.67 degrees, which makes this one here, what, 45.33 degrees? If we subtract them from 180. 180 minus that angle minus the 78. 45.33 degrees. Now we have all three angles. We can come back and find our final side. I'm still going to use the 48 over the sine of 78. Side B is going to go over the sine of that new angle B. And we cross multiply and divide. 48 times sine of 45.33 divided by sine of 78. 34.90 looks like. That's not degrees, that should be millimeters. So this side is 34.90 millimeters. So this deal where you have to do the inverse sine, you should never have to do that more than once in a single problem. So now the next example we want to look at, what happens when we do have an obtuse angle? So let's say I tell you that this angle here is 18 degrees. That this side here is 24 millimeters, and this side here is 13 millimeters. I'm going to label this A, B, C. We have two sides in an angle, so remember the first thing we have to check is the angle opposite one of the sides? Well, the 18 degrees is opposite 13 millimeters. Good. So we do have that. So we're going to have 13 over the sine of 18 degrees. So now we have the 24 over the sine of angle C. Now here we have a drawing, and this drawing is pretty obvious that angle C is obtuse. When it's made this obvious, we can go ahead and assume that it's obtuse. So let's go ahead and cross multiply to get the sine of C here. So it's going to be the sine of 18 times 24 divided by 13. So 0.5705. So then we're going to do the inverse sine of that. So second sine, second answer, 34.78. What's that tell us about C? It's going to be the supplement of 34.78. So 180 minus 34.78. is going to be 145.22 degrees. Make sense? This is one that a lot of people get wrong on quizzes and on tests because they just write down this answer and they don't stop and adjust it. But because we know it's obtuse, we've got to take that extra step. We've got to find its supplement. Well, now, of course, we can find the last angle here. That last angle is just going to be 16.78 degrees. We're just going to subtract those other ones from 180. And then I could find side B. We've got the 13 over the sine of 18 is going to equal side B over the sine of 16.78. So we cross multiply. 13 times the sine of 16.78 divided by the sine of 18. Oops, what did I do? Let's try that again. 13 times the sine. Would it be 26? Yeah. Check again.
Oh, what's the other angle? 145?
145.22 and 18.
Oh, yeah.
Skipping class and showing me quick questions.
So I get 12.15 for B. Hey, at least you're following along and trying to double check me. That's appreciated. I've had those days where I've made some pretty obvious mistakes and people just sit there and watch it go.
Oh, I read at the beginning when they're first like a long time. Yeah, they just like first go to the field and they see like
They knock them down that far away from the big man part. They're so cute. Maybe watch it move more often.
The big kid was the one that got fucked.
Okay, so what I'm going to do here now is I'm just going to give you the pieces. I'm not even going to draw the triangle. Looking at this information, can anybody tell me what the problem is? Well, first remember we have two sides and one angle. Whenever we have two sides and one angle, the first thing we got to do is we got to ask, is the angle opposite a side? Yeah, angle A and side A, those are opposite. So that's true. That's a check mark. The second one, though, is the opposite side smaller than the other. Smaller or larger, however you want to do it. And in this case, it is smaller than the other, which means there's two possible triangles here. I could have a triangle where this is the angle, 23 degrees. That's A. This is my side B here of 33 millimeters. And this is my 19 millimeters here for side A. Or that triangle could look like this, where this is the 23 degrees, this is the 33 millimeters, and the 19 millimeters folds back in like this. So what that's telling me is this opposite angle right here, which would be angle B, because it's opposite my side B. We don't know from this information whether it's acute or obtuse. So there are two possible triangles that could be made here. Or the other possibility, which we saw in one of our examples yesterday, or there's a possibility that there's no triangles. Now, I picked these numbers carefully so that I know that it does make a triangle. What sometimes happens, though, is this opposite side here is too short. That with an angle of 23 degrees here and a side of 33, let's say if I made this like 11 millimeters instead of 19, 11 millimeters would not reach all the way down to this side no matter which way I put it. It's too short to make it all the way down, so it doesn't form a triangle at all. It doesn't close. So that's the other possibility, is it could form no triangles. In this case, though, I've made sure the numbers make sure that it works. So here we need another piece of information. We need to be told, is angle B acute or obtuse? If I tell you that angle B is obtuse, then we can proceed. So we're still going to start out with side A over angle A, 19 over the sine of 23. Then we've got side B of 33. It's going to be over the sine of angle B, but we know B is obtuse. So we're going to cross multiply. Sine 23 times 33 divided by 19. So I get 0.6786. So B is going to be the inverse sine of 0.6786. So do the inverse sine of that answer. I get 42.74. Well, because this, when we cross multiply and divide, we get the value of this, and that's the value of sine of B. So then to get the actual angle, we have to do the inverse sine.
That'd be for if it's obtuse.
Either way.
Yep, either way, obtuse or acute. If we're looking for an angle, we're going to have to do an inverse sine, because when we cross multiply and divide, that decimal that we get is the sine of that angle. But now in this case, since we were told it was obtuse, now that we have done the inverse sine, we do have to do that extra step of 180 minus the 42.74, which is going to be 137.26 degrees.
Oh, so those are the two possible answers.
Those are the two possible answers, yes. Then you'd have to solve it twice and have two different possibilities listed. I will always give you a picture where it gets to be tricky. So of course that's the angle for B then. I'll write that in 137.26. And you find angle C by subtracting, and then the rest of that's pretty straightforward. The only time where the picture is really kind of tricky is when the picture looks something like that.
But that other angle is acute, there was that triangle was inverse.
Yeah.
How would you want? I mean, I know I can.
I mean, this triangle up here,
Yeah.
if this one was acute,
Yeah.
if you were told this was acute,
Yeah.
well then you just would have put in the 42.74. You have to either be told that information, or you have to have a picture that makes it obvious. So I'd say in this one here, here's one where now there's a dilemma. Let me show you what I mean. So label this A, B, C. So little a, little b, little c. When I go to solve this, I've got 6 over the sine of 36 equals 8 over the sine of, well, I'm going to remove that. I'm going to get rid of the 8 there. I'm going to actually do this. To make my example work to show you what it could be, I'm going to put the 10 there, so the 8 down there. So this is going to be 10 over the sine of C. In this picture, C looks like it could be a right angle, doesn't it? But it's not quite. So when I cross multiply and divide here, sine of 36 times 10 divided by 6. I get 0.9796. So the sine of C is 0.9796. So C is the inverse sine of 0.9796. But when we do the inverse sine of that, we get 78.42 degrees. So looking at that, I was trying to get it to come out to like 87 or 86 degrees, somewhere in there, but that's still kind of close to 90. It's really hard to tell the way this is drawn, whether that's 78 or is it 102. And that's where you have the problems with working off the drawing, is when it's right around 90 degrees. Like I said, this one didn't come out as close as I was hoping for it. You know, if it comes out to be like 86 degrees, well, you can't possibly tell from a drawing unless something is indicated, whether it's 86 or 94. So that's when you have to have more information, or you just have to solve it both ways. On a quiz or a test, I will try to make it obvious. If it's not obvious from a picture, just ask me and I will tell you. Okay, well, these are one of those. This is the type of problem that you just have to practice to make them, to understand them. So we're going to stick with that second page from yesterday. We look up what it is just to make sure we've got everybody on the right shot here. On page 381, 1 through 17. Some of them are actually solving the triangle, and some of them are actually doing what we just did up here, where you look at it and just say, hey, is this going to be one triangle, two triangles, or no triangles? Okay, I'll let you guys have the last 15 minutes or so here to get started on that homework.